All right. Now it's also recording for YouTube. Great. So, by the way, if you're watching the lecture live, you want to be on Twitch, of course. If you are going to be watching the lecture like in the afternoon after it's live because you missed it, then you want to watch it on Twitch because it'll be available right as soon as the stream ends. Except the only catch with that is that you'll have to scroll ahead of the 302 lecture because it's the same live stream. So you might have to skip like an hour and a half approximately. That's not approximate, it's pretty exact. Because if I start to stream like at 3:55 p.m. and class goes from 4 to 5:15, then yeah. But this class starts at 5:30, so yeah, it'll be an hour and 35 minutes pretty much. So just beware, that way you don't get confused. And then of course, around midnight or later, I will be uploading it to YouTube. Well, I upload it as soon as class ends, but it takes time to process the video, so. And I have to upload 2 lectures, the 302 and 202, so yeah. So as long as you're watching it, the same day, you can do Twitch. If you're watching it the day after, then do the YouTube one because it's higher video resolution because it's a local copy. And it should still have the Twitch chat, so you won't miss out on anything. So, yeah. That could be a good or bad thing because the Twitch chat will be there. Okay, so yeah. All right, so basically last time we were coding this really fancy class and we didn't finish it, so we're just going to work on that today. And just hopefully we finish it today. I mean, at least our first iteration of it. And then we're going to expand it with the inheritance stuff after we talk about inheritance. But first, I want to finish this because last time we had to rush a bunch of the ending stuff because I wanted to show you something working, but that meant like Russian code. So this is why you should write documentation because now I have no idea what this code does. We wrote it a week ago and it's gone. So let's kind of go together and see what the code does. So we have the class Tamagotchi. Yeah, I remember that much. We have an HP variable for health, whether it's alive, it's hungry, current time, last fed time, and start time. So the reason we had all this time stuff was because we were trying to make it so like it would ask us to feed it after X amount of time passed. Yeah, okay. So there was that. Okay. We have a constructor to initialize things and also to default everything if we don't pass any parameters. Then we have a function to print the current time, to print the start time, to ask if whether we're hungry or not, because we want to do the most object-oriented programming thing we can do is just to make everything functions and not access variables directly. And so that's why we have, things like I'm hungry that would check if we're actually hungry versus just returning the Boolean directly, like by accessing it. Okay. We have a feed. We have to figure out we're alive, to get the current time, to get health, and the update function. Right. Yeah. This update function was to basically do all of the all of the processing that the game will do each frame per se. And so that's a function that basically updates all the variables every second that goes by. Now, in the world where we have a lot of time to do this assignment, we will do something known as a synchronous input, where like the world will still be running, this update thing will be running constantly, like repeatedly, like just going in circles. And then separate from that, we would have a thread that would check for user input. And as soon as we had user input, then it would stop this, like update this calling constantly, like stop, feed it the input, and then keep going and process that input. That way, the game could be running even though we're not feeding it input. But that requires a synchronous input, which is something that you learn all the way until 370. So you can code it easily in with something like end cursors, but you can't really code it in easily like right now. It would take us too much time. So we are not going to do that piece of asynchronous input. Maybe I'll do it behind the scenes at some point over the weekend, and then I'll show you what it looks like that way. But for now, that it will be the catch. So what that means is that we are going to have to manually hit enter or enter some information to keep the game going, so it doesn't stop waiting for our input. Okay? That's just one thing that we're going to have to do. Okay. So with that said, we have an update HP function where you update the health, but we want to make sure we don't give it invalid values over 100 or less than 0. That's one of the advantages of using functions instead of modifying variables directly, that you can control to make sure that you don't feed invalid data. You know, you're only feeding it data that actually works. Okay? So avoids having to figure out why your game is crashing, only to figure out that one of the developers, you know, was decreasing the health on a function without checking if that health was 0, giving you negative health, which was sec faulting the program or a game. You know, that's the kind of stuff you want to avoid. Okay, so our update function was rushed, so we're going to completely rewrite it into a nice and clean update function so that we can take advantage. But really, all of the class stuff is pretty much done. So really, we're just making this nice at this point. So the first thing we do every time we call the update function is we want to update the current time for the program, right? We want to pull out the current time from the Linux clock, the computer clock, and see what time it is. Okay? And we don't really have a function to update the time. We can write our function really fast to do that, or we can just do it in the update function that we have here. So we'll leave it as it is for now, okay? Next, we are checking whether we're hungry, and if we are hungry, we are printing a message and we are updating the HP. This is something that we should really move into its own function, okay? So I'm gonna go ahead and write a function called hunger check. First, we're gonna write what the class name is, so Tamagotchi, and then hunger check. Okay? And make sure you don't forget to put in the prototype up here. It's going to be a private function because this is a function that I only want internal access to. I don't want people to check this function manually because that would cause potential issues. And in this function, I am literally just going to take what I currently had in update and put it in there. Okay? So I'm going to call another function called I'm hungry. I'm going to print out to the screen hungry. Obviously, if this was a well-done game, you would not do this. You would actually call a routine that does the printing. But we'll just hard-code it in here because, again, this is quick and dirty. I do want to add a line feed to this. And maybe I am hungry, something prettier in terms of output. And then I want to update the HP to decrease it by 1. Update HP is a internal function as well. So it already has checks to avoid negative health. I believe. Let's see, if H is less than 0, H gets 0. Yep. So I don't really need to worry about feeding it invalid data because it will ignore it. So it's perfectly fine for me to do HP minus 1, okay, as the value that I'm passing in. That is perfectly fine. I could also write a function called decrease HP, which would literally just do this, but it's fine because this is an internal function, okay? So now that I've done that, I can just go ahead and call hunger check here, and this looks much nicer now, okay? The next thing I want to do is take some sort of user input, either to cycle the game, because again, we don't have a synchronous input, and also to cycle what command, so things like feed and whatnot, okay? So let us write a function called take command. Oh, that's a good point. You know, thank you for doing the points. So with the Twitch system, now we have channel points. So the channel points can be used as to be redeemed for extra credit. Like I believe I set right now 10,000 points as the requirement to redeem, but at the end of the semester, people are gonna have like a certain amount of points that may not be exactly 10,000, so we'll have smaller sort of point redemptions. But I like to have a big one because then I don't have so many things to go. So the process is redeem it and then send me a message on Discord or email or Canvas and put your Twitch ID, your Twitch username there and your real name there, and then I will give you the points on Canvas and then redeem and then claim, you'll redeem it here and then I'll mark it redeemed. Okay, so that's how it'll work. But you have to redeem it for the extra credit. So if you do for anything else, you sort of throw away your points. So yeah. Well, thrown away, but you know, you don't get them for extra credit, I guess. So yeah, that's how that works. So yeah, and you get the points by just being here. And I think you get more points if you write stuff in the chat, but I'm not sure. But at least you gotta make sure you're at least logged into your account so that it links into your account. Okay? So yeah, I just forgot to say that earlier. Anyways, going back to the game, we are going to call this function get user input. Okay, and this function is going to basically read in some user input, which we're going to say is an integer. We should error check it, to be honest with you, but that would take too much time to do right now. So we'll just assume that it's clean and safe, okay? But really, you should sanitize your input. All right. So once we do it, we should parse that into a enum of different commands. How about that? Is that too fancy to do right now? I haven't done an enum in a while. I have to Google the syntax for an enum. There we go. Okay. So it's really just like writing a class. Perfect. So we're going to call this Parse Command. And what it'll do is it will take the number, feed it to the enum, and return to us what we are supposed to do. Is that going to be useful like that? Yeah, maybe. Maybe. We might modify this later. Get user input should also be a private function, so we're going to make it private. I'm just trying not to make too many functions because it's more work right now. So let's just make the enum first, and we might not need that in there. So the enum, we can actually make it as, yeah, this is good practice. Let's make it as a static. Can we actually, they're also technically static, but let's at least put it as a member function of the class. Okay, so let us put here enum command or p command, player command, and then let's say command 0 is nothing. So basically do nothing. Do nothing. And then command 1 is feed. Command 2 is kill. Command 3 is, what else do we want it to do? Well, we want to do a lot of things, but for now I think that's going to be more than enough. So I like to make my last enum to be the size of the enum. So I call like size or something, or max. So that's just good practice. Okay? So by doing that, I can call process command user input. And then I can make another function process command good. Oh, forgot one of those. Where I'm actually going to process that. Okay? So, command. The command that we're going to do is say if do nothing, then we just do nothing. So do nothing, so just return. Now this is where your code grid would complain, right? Because we have multiple return statements. So I guess we would use an if-else-if statement to avoid that. Okay? Else if the command is to feed, what is it? Feed or kill? Feed. Then we'll do something for feed. And then otherwise, the command is to kill. Command is to kill. That sounds very scary. Then do that. Otherwise, right now, since we have nothing else, we'll have one case that says invalid command, which will do the same thing as do nothing. Okay? So that will take care of that part. So now what we want to do is we want to feed all this stuff. Interesting. We want to pass all this stuff in there. So I guess for feed, we call the feed function. And we're good to go. And then that's it. I guess, technically speaking, for the hunger check, we should have put this code here to see if we're hungry or not. So where's our hunger check function? If current time and its last fed is hungry, it's true. Okay, so I guess we'll update that there. So I guess it says, well, if the current time, and this is the stuff we did like last second before class ended, so try to remember it. So what we did is we have a current time minus the last fed time, and if that is greater than 10, we say that we're hungry. So I guess every 10 seconds we're hungry by setting the value to true, which I don't like modifying that. So we'll make that a private variable. Instead of set, well, I would give hunger would be better, but I'll call it set because we want to do some nice naming convention. So void Tamagotchi set hunger. Why is it not showing up? And this literally we just do is hungry. Yes, true, because then that will make the code cleaner, more object-oriented programming. We'll call set hunger like that. Okay? So the idea is you want to have all these functions for everything you want to do. You don't want to just directly modify variables and things like that, because it's much easier to read. Like, okay, if this, in fact, I would even update this current time minus last fed. It's probably a nicer way of writing that piece of code. But that would be going a little bit too excessive for the time we have. Okay, but ideally you just want all functions all the time kind of thing. For kill, do we have a kill function? We have it's alive, so yeah, we'll just directly modify that. So it's alive, so we'll set that to false in the kill one. Where's my function that I'm looking for here? Sorry, I keep moving the screen around. I'm looking for a function. Process command, here we go. So I guess we will call kill. And then we need a function for kill. So void Tamagotchi kill. And we definitely want to make that a private function, because you know things are going to break if you don't. Someone's going to call it when they shouldn't and kill the thing. Okay, so all I'm doing right now is cleaning up the code that we did last time. So for the kill, we're going to set is alive to false. And then see out Tamagotchi is killed. Instead of has been killed, is killed. Right? From that live, die, repeat. Okay. Once it's killed, though, we probably want to end the game. So we want to add a kill check. Okay. I could make another function, but I'm just going to call is alive and say not alive, just to kind of get this done quickly. All right, we just return. So that basically that ends the loop because the game ends if you die. Okay. So did we move this already to the hunger check? Yeah. So I don't need to have that in there anymore. Okay, perfect. So let me get rid of this. Like that. Okay. And so now we could make the game run forever. In fact, let's do that. Let's make it run forever. We'll just kill it whenever we have to end the game. Okay. And that's it. That's all you need. You just need to call update once. Well, actually, I need to put this in the loop still. My bad. So just while true. And then that will basically run forever. In fact, I would make that a function of its own. That would be a good function to do. So void Tamagotchi run game. And literally just throw in this in there. And then I'd actually call this function, make it, I could make it a public function, that's okay. For that one, I think it's a good function to make public. In case you want to run the game from a different process. However, I think to make the game run when you make an object, let's just throw that in the constructor. Let's go run game there. And then, just because, you know, I should show you an example of a destructor, why don't we make a destructor for this that just literally says game over, and that's it. That gives, like, you know, not really other use for this, so. Game over. Okay? So, you're all really quiet. I hope you're all there still. So, yeah. All right? So yeah, now what we've done is we've taken the code that we had last time and we just kind of cleaned it up and made it a little bit nicer. Okay? Any questions? We're probably gonna run into some compilation errors here, but that's okay. We will basically fix them. Probably a bunch of. Oh, we only got one. Process command user input. Semicolon. And then try to run it again. You just died. Where are my errors? There we go. Let's see. No matching function call for process command. We probably misspelled that. Process command with 2 S's and 2 M's. Command user input. Oh, we forgot to put the variable. I'm gonna pass an integer there. Okay, 3 errors now. Tamagotchi, what? Tamagotchi. We really screwed up that spelling. Tamagotchi. Okay. This should be update only. Still doesn't like that. Void Tamagotchi. I don't know, just write it. Kind of glitched out. Okay, and finally, this. I don't know why I put an del there. This should just be like that. Okay, it is working. All right, thank you all for your inputs. All right, so as you can see, it's like spamming "I am hungry" nonstop. That is okay. I don't think we have call get user input in the update function, so we will do that. Probably do it actually at the beginning. So this is the part that if you did a synchronous input, this would be a synchronous function. So this would not be a halting function. What it means right now is when the code runs and it gets to the function, it stops and it's going to wait for me to enter something. if you use something like end curses or threading, multi-threading, then you could make that asynchronous so the game could keep going without stopping there. It would only stop if there's input given. Otherwise, it would just keep going, which is how real games work. So right now, when I run it, it just stops because it's once input. So then I can enter 0, which is my, don't enter it there, here. That's the do nothing command. In fact, maybe just so that we can see that the inputs are working, I'll put a cout that says do nothing. So like input do nothing. Okay, and then I'll do the same thing for the other ones. Feed. Okay. So I run this again, and now it's gone crazy. Why? Thought I called the get function. Where's my update function? Oh, it's gone. What happened? I must have deleted it. There we go. Okay. Run it. All right. So now it's waiting for input. So let's just put a do nothing. Input feed. Input feed. I must have copied things wrong. Why is that feed? I think I must have screwed up the this things, the enum. Do nothing, feed, kill, esize. This would be 0, 1, 2, and 3. Okay, let's try 1 and see what happens. Feed. Feed. Okay, it's something's wrong with the if statement there. Okay. Int user input, process user input. Process user input. Where are we with that? Where's process? I should use Control F at this point. See, this is the problem when the code gets too long, and like it's so zoomed in that it's so hard to find things. There we go. If do nothing. Fail. Mega fail. Mega failed. Do you all see what I did wrong here? You know, in my mind, I think I was thinking like switch statement, and that's why I did what I did, I think. But yeah. What does anybody see what's wrong? This is a good question for you all. What is wrong? Why is it always going to feed? Do nothing is a 0, so if 0 is false, so it doesn't go there. Feed is a 1, so it enters there, right? But so what do I need to do to fix this code? It's very trivial now that I've seen the error. But let's see if anybody can see it too. So drop some suggestions. What's wrong with this code? I have to change 3 lines of code to fix this issue. Yep, 3 lines of code. I don't know if there's delay on the chat, but come on. What do you guys think I need to do to fix it? Do valid check instead of checking if it's true or false. Yeah, so I have to do valid. So I have to take the CMD parameter and compare it with this. So I have to say like if CMD equal, do nothing, then do that. So yes, exactly. So I have to do this. Yep, exactly. You're all good. Yep. So now it'll work. So yeah, I think in my head I was thinking like switch statement or something. I don't know why I didn't put that. So yeah. All right. So let's stop the program. It's still running actually, and run it again. Okay. So now fingers crossed, we're all good, right? This is ready for production, right? Okay. Do nothing. It's hungry. So if I keep doing nothing, it's gonna be hungry. And you know what we should add to the logging? We should print out the HP. So that we can see the HP going down because he's hungry and we're not feeding him. We should totally do that. So maybe we'll just put it in the update really fast. But maybe actually no, let's do it on the hunger check. Let's put it under the hunger check. Oh, better yet, if he's hungry, no, we'll do it outside here. So we'll say log HP. And then what's the HP called? I think it's just called HP. Okay. And then also when it's hungry, it can print out its HP as well. Yep. Okay. So, all right. Log. I am hungry. So you can see how if I keep pressing enter and do nothing, it is going down in HP. Let's see what happens when it gets to 0. I should have made the HP a lot smaller than the 100. We'll get there someday. Okay, here we go. We're getting there. Ready? And the HP is at 0, but the thing didn't die. RIP. That didn't work. Okay. Why didn't it work? Let's see. Hunger check. See out. If I am hungry, update HP. If H is less than 0, HP gets 0. If HP is less than or equal to 0, is alive gets false. So it should be dead, but it's not. If is alive, which is false, return. Debugger time. Let's put some breakpoints and see where this is going. So let's put a 0 again. All right, we hit the breakpoint. This is why debugging is nice, because we can see what happened here. So it goes to current time. It gets the user input. So I type in 0. All right, it does the hunger check. So let's go into the hunger check. So if current time, let's say is later than 10, set hunger. So it goes to hungry. Hungry is true. If I am hungry, are we hungry? Return whether it's hungry. Yes, we are. See out. I am hungry. Update HP. This is what we want to see. So if H has a -1, which means it should kill it. If HP is less than 0, make it 0. So we fixed that issue. If HP is less than or equal to 0, its alive should be false. So it is setting its alive to false. The question is, when it goes to the bottom of this, you know, it logs the HP. The HP currently has, see what the HP currently has. 0 in it. So the HP has 0 in it. And the is alive variable is set to false, which means it should be dead. So here, we go to the if statement where if is alive is false, which is true, then it should return. Okay, that explains it. Yeah, okay, so it is returning from the function, but then it's going back into the function. So what I need to do here is tell it that when it returns, it should quit out of the function if it's returning from this parameter. So instead of calling return here, how can I kill it from here? I mean, I could call exit, but that's kind of a violent way of exiting a program. So I could pass a parameter in for the status. So yeah, I'll say if is alive, return 0 or return 1. No, it doesn't really matter, but whatever. Otherwise, return 0. So then make this a valid returning function. That it's a boolean actually. We'll make it an int. Okay. By the way, you just saw right there how a debugger literally helped me find the issue. That issue could have taken me hours to find if I didn't have a debugger. So I hope, for your sake, that you're using a debugger, because as you can see how nice it is. Like, it told me what was happening. It made it. It wasn't like, it didn't just say like, okay, you're returning from a function anyway, so of course it's not going to end. It didn't say that to me, but it made it obvious when I got to that line. Like, oh, okay, this makes sense now. It's returning anyways. That makes sense. So, yeah. Okay, so by doing this, now I can actually switch this from true to say int stat, set this initially to 1, or actually just, oh, here, let's make it to 1, but then let's switch these into 0 and 1. And then actually, oh, we want to be fancy, we could do this. We could do that, and then that'll work actually. But that's pretty unreadable code, so I would defer you from doing that. So while that should work, I would leave it as stat, and then here put a line that says stat gets update, like that. Okay. So now when it dies, it will actually kill it. However, let us change the default HP to like 30 or something, because that was a long time for the startup. So the default HP, if we don't pass an HP, is not going to be 30. Okay. I don't have to type. I literally have to press the key 200 times, like one for one and one for the other one. So not fun. Where am I semicolon at? Okay. All right. So let's turn off the breakpoint, hit play, and let's just spam zeros. Okay. Bam! It worked. This time it died. Game over. So it said game over. So yeah. Okay, so it died. I mean, I could have put a message saying like rip or something, but at least it said game over. So it worked. Okay? So we are in business now for death, at least. We have achieved death. Let's see if the feeding works. Okay, so test number 2. It's hungry. Let us feed it. We have fed it. So now it will do nothing for 10 entries, or 10 seconds actually, before it becomes hungry again. And when it becomes hungry again, it should start losing HP if we don't feed it. As you can see there. See that? Let's feed it again right before. And feed it. So we fed it. So it's good to go. However, something I noticed, when we feed it, we don't regain HP. We just stop losing. So that means death is inevitable. Unless you don't forget to feed it. See that? Let's try to just kill it. Flat out. Bam. We press 2 for kill and it kills it. Tamagotchi is killed. So in that case, we do get a confirmation that we killed it because we killed it ourselves instead of starving to death. Okay? So there you go. That's the entire game. That's the whole code. All right? Like I said, this will be uploaded. I want to remind you on where that's uploaded because you might not see it obvious, like might not be very obvious. But if you go to Canvas and then scroll down to where it says this one right here, the second link, video lecture livestream uploads, you click on that, and in there you can see the playlist for the YouTube videos. And here, right here, this here is going to be all of the code. So if I download this right now, like this would literally give me the latest version. So the page will look the same, but behind the scenes, I am constantly updating that file at the end of it every week. Okay, so like tonight I will upload it with the code from today's class. When we have class normally on like Mondays and Wednesdays, Monday I don't update it, but I will update it at the end of Wednesday because once a week is good enough. By the way, I have all the examples from last semester's, or not last semester, but last fall's class, all the playlists here, and I have all the examples here. So that's another resource to see like tons of examples as well. Okay, so you can check that one out. And that one won't change because semester is done. Okay, so again, that is found under the module at the top. This one right here, okay? So, yep. And then I will get you assignment 3 tonight, okay? So this is not the end of the Tamagotchi though. We're going to do inheritance next on it. But first I want to show you what inheritance is. But first, anybody have any questions about the code? By the way, we wrote 135 lines of code. So that's pretty cool. Not that the number matters. If anything, less lines is better. But you can see here how we got tons of functions, you know. So the idea is how clean the code is, like to read. The update function is like, okay, this obviously gets user input. This checks if we're hungry. This checks if we're alive, and returns. I don't like that returning thing for this, but you know. Why can't we put else statement after the return? You can if you want. that'll work the same way, but it's one less line of code, so that's why I didn't write it. Delegating constructors. What do you mean by delegating constructors? Like, well, when we talk about inheritance, I think that will make more sense. I'm not sure what you mean with that, but yeah. Yes, it will be. That's what I'm saying. This is literally up that one file that I told you. So like right here, this one. So you click here. This file will always have the same name, but it will contain all of the samples that I run every day. Okay? So you will basically see that there. Check tonight. So, oh yeah, there's a 10-minute timer, right? So yeah. That's to prevent when we like DDoS from bots or something. So yep, okay. So this is not the end of that, but for now we will switch around to it. Yeah, well, for that you need to know operator overloading, which we haven't covered yet. So yeah. Okay. So let's talk next about what inheritance is. Okay? So right now, if you think about what we did with the Tamagotchi, we created a class that contains a lot of useful things, such as the HP, such as being able to feed something, being able to kill it apparently, being able to check whether the game is updating or not. We basically have a lot of features, right? And we go ahead and we publish our name and publish our game, and you know, we make millions of dollars or something, right? Okay, it's been very successful, Tamagotchi thing. But then investors come to us and say, like, you know what, the game is great, but like, wouldn't it be great if we could add and then insert whatever you want there? You know, we could add cats instead of dogs, or add the ability to take to play with it, or do this or do that. That's just bound to come with any project. You build these classes and these objects, and people want to enhance them or add more things to them. So one way that you could do that is you could modify what you currently have. But you may not want to do that because you might still want to use it. You might still want to use it and have this coexist with the other version, right? Furthermore, when we talk about, when we do talk about polymorphism and whatnot, you may want to have a common class that is shared between all the different types of Tamagotchis, whether it's class Y, class C, or class G of Tamagotchi, like fire Tamagotchi versus water Tamagotchi or something, right? They all have a common core. And so you might want to keep that core the same, but then expand them to have sort of special characteristics, right? Or if you're selling your DLC and you want to sell some additional skins and pay to win features, right? But you still want to keep the core for the ones that can't afford the DLC and make them feel bad. So all of these reasons, you want to take code that you have and enhance it without modifying the original code and still being able to use that. And so I guess the simplest way to do that you could do it with what you currently know, is you could copy and paste the entire code into a new file and then change the class name and then start modifying things. And that would work, that would technically work. I mean, it would be a solution, but not the solution that we really are looking for, okay? So you have your Tamagotchi class, which we're just gonna call the T class. And then you want to enhance that. So the simplest way to do that, of course, would be to copy paste. So you copy paste it, and then you enhance it with your extra features, which kind of are built on top of the previous one, right? So this is one way that you could do that. And sure, it'll work. It'll be a pain, a real pain to work with, but it would work. And so these are all your extra features here. So like, I don't know, the ability to sleep, the ability to change colors and to play and speak or fight with other ones and whatnot, okay? However, what happens if you find a bug or an exploit with something here? Well, you can patch it, assuming you can figure it out how to patch it. But now you got to copy and paste your patch over here and hope for the best as well. Or if you want to modify a core thing of this, like maybe what we did, we changed the HP. We want to lower the HP to 30 because balance reasons. So we got to lower something. Well, now you got to remember to copy and paste that here into the other one, right? So it becomes kind of like you can think of like a version hell. You got to keep track and copy paste all updates, right? And if you forget to do something, you might patch things in the base one, but not the copy paste one. So now you got an exploit there, and things go really bad. So hopefully this is convincing you that like copy and pasting may not be the best way to approach this. So what else can we do? Well, we could make it from scratch and entirely different thing, but that's not really viable. So what we do is we use inheritance. What inheritance is going to allow you to do is it's going to allow you to take a class. We're going to call this like class dad, or not dad, class parent. Okay, we're going to take a class parent and we're going to inherit all its traits and characteristics into a new class that we're going to call child. The child class is going to have a reference, you can think of it that way, to the parent class. Meaning that all the stuff that the parent has, the child has. And if you modify anything in the parent class, then it'll automatically be modified in the child class. But, here's the cool part. You can add extra functions and variables, so extra features, to the child class. And now we solved our problem. Because now, we can keep adding stuff to the child class, but if we change up something in the parent, the child will automatically be updated. So, in terms of code, if we have a class A, which contains like a variable x and a function foo, that prints out said variable x. And for now, we're going to just make everything public. So if you have something like this, okay, I don't know, just whatever, don't worry about it, okay? Yes, we can see your message. So, yep. But yeah, so if you have something like this, and then you're like, well, wouldn't it be so cool if we could have a variable y and a function bar, but still keep int x and foo? Then inheritance comes to the rescue. So we're going to make a brand new class. We're going to call this class B. And we're going to inherit from class A. Don't worry about this word public for now. But you already kind of know what it means. And now, here, I can go ahead and put an int y and a function bar, or whatever I want. I don't have to, by the way. I could make it the exact same, but then why would you do it, kind of thing. You're just kind of cloning it, I guess. And then there you go. So the power of class B is that, if I go in my main client code and I go in and I create a object, or I instantiate, my B class. So I say something like B new B. I don't like using the word B. So here, let's use lowercase b. BB, like that. Then, I can, since it's public, in fact, let's also make these public. I can say like by gets 10. But I could also say bx gets 20. And this x is coming from the a that's been inherited. I can also call the function foo or bar. However, if I make an object of type A, then it only has access to the x and to the foo. If I try to say a.y, then that won't work. Okay? And then let's say in the future I want to modify my class. I want to change this 5 to be an 8 or default. Then it'll automatically be updated in every other inherited class. Why are my functions named foo and bar? Good question. Good question that I can't fully answer, because foo and bar are like the traditional names for picking a name for. So like, okay, in like 135, when you're writing a for loop and you're saying you gotta put a variable there like for int I equals 0, I is less than something, I plus plus or whatever, and you're picking I all the time, I come back and ask you, why do you always pick I? It's just something you traditionally do. You pick I, j, and k as your variables in for loops. And with foo and bar, it's just something that at some point somebody came up with, and then everybody just copies them. So, yeah. I do know that foo bar is that, but I don't know if that is the same reason why foo and bar come back from this. Especially because foo bar here is spelled like FOO, and that's like foo bar. So I don't think so. I don't know, but who knows? So it's definitely a good question for the internet to find out what the history behind that is. There probably is some history, but even Google's secret interview system is called Google Foobar. It's just that's literally it. It's like Google.foobar or something. It's like Google.foobar, I think, or foobar.google. So this is something that goes like beyond even like I'd say that's like an international thing at this point. So maybe inside joke. Yeah, that could be it. So yeah, but anyways, I kind of picked up that tradition as well. Probably it's like your first program should always be called Hello World kind of thing. It's one of those traditions. Who knows? I'm not superstitious, but like it might be like a superstitious thing. You want to make your first program be Hello World. So anyways, yeah. So if you see that, yeah, it's not me trying to like secretly send commands to like Secret Army or something. I don't know. Okay. So anyways, this is how inheritance works. You syntactically, what you need to do for inheritance is you are going to write the keyword class. I did it over there, but I'll say it again. Then you're going to put your identifier for the new class, and then you put your colon, and then you got to put here whether you are inheriting publicly, privately, or protected. Otherwise, the default will be a private inheritance. So that has a name that just left my mind for now, but it's called the classifier. I think it's called like classifier or something. Why can't I shrink this? Come on, there we go. So really, here you want to put two things in pairs. This is going to be the identifier for the parent class. So whenever you're dealing with inheritance, there's three names that you should know. Okay? So the idea of having the parent and the child, that's one name that you like to use for inheritance. But there's also superclass and subclass, and then there's also one more: parent, child, superclass, subclass, derived class. Yeah, derived class. So I guess just a class and a derived class. Okay, so derived, sub, parent. Sorry, derived, sub, or child, they all mean like the child class, and then the parent is either super class or parent, I suppose. Okay, so just so you're aware as you browse the internet that other people might use these terms. Okay, I tend to use parent and child. Sometimes I say derived. I don't really use super and subclass. The Java people love that though, so you might see that in 326 when they talk about Java. But yeah, and then here's just going to be your classifier, which can be public, can be protected, and now we can finally talk about what protected means. It can be private. The default, by the way, will be private. I would say that most of the time, at least for this class, you want to put public in there though, okay? If anything, you maybe put protected in there sometimes, but very well. You won't need to put private because that's the default. But you probably won't even need to use private. You don't usually inherit privately. But let's explain as to the why. Let's explain as to what that does. Okay? So, and then by the way, after that, you can use your curly brackets and start your class. And by the way, you can do multiple inheritance. I'm not going to talk about that today, but I'll talk about that next time. C++ does allow multiple inheritance, which causes its own great fun of set of problems. Protected is not useless. Protected is not useless though. Protected is actually useful here. It's useless when you're not doing inheritance because you can just say private. But here it's going to be useful. So let's go back to our little table that we did at some point. So to review, we said that the public classifier for variables and functions means that you are able to access those members, whether they're fields or methods, functions, procedures, whatever you want to call them. You're able to access them inside the class and outside the class, right? You can access them inside and outside because it's public, kind of like a struct in 135. Private, on the other hand, you can access the variables inside the class. So, when we're doing a Tamagotchi example, we could access the variables that are in the Tamagotchi class from any function. Whether the variable was public or private didn't matter. Protected acts the same way as private when it comes to inside the same class. Here's where we change things and we update things. Derived classes. So remember that? Now you see why I use the term derived up there. When it comes to inheritance, let's just assume right now that you are doing public inheritance, which means you write the word public before the parent class, okay? Even if you do that, think about it this way. You can't make a variable less secure. You can only make it more secure, okay? So if you have something that is already public in the parent class, and now you are creating a child class, and you are inheriting publicly, then that variable will remain public. However, if you have a variable that is private in the parent class, and you're inheriting publicly, it's going to remain private in the derived class, but you're going to have problems because the derived class will not be able to access the parent class's private variable. Now, that doesn't mean it doesn't exist. It's definitely there. However, you're going to be the same way as if you were just a function in main, where you can modify that variable through any of the public methods or functions that are in the parent class. So like in the Tamagotchi, for example, HP is private and it's part of the parent class. Well, we only have one class. If I derive from the Tamagotchi class, I can still update the HP using the update HP function, but I can't modify the variable directly because it's private in the parent. Is this good or bad? It can cause some issues because again, the idea why we're making this derived class is to enhance the parent class. And we may want to actually access the variables while we're enhancing it, as long as we're doing it internally within the class. If we make it public, yes, we can access them, but so can anybody else. This is where protected is going to come to the rescue. Protected gives you the best of both worlds. Protected does not allow the public world outside of your class to modify that variable. You have to use other public methods to access it or modify it, and you can filter any bad input that way. But for the derived class, inheriting a protected variable will allow you to modify it in the derived class. So you'll treat it the same way as if it was a private variable in your class, okay? So to summarize, when you're dealing with just one class, private and protected do the same thing, which means only you can access it, nobody outside of your class can. When you're dealing with a derived class, if something is public, the rules stay the same, anybody can access it. If something is private, you can't access it, the parent class variables. You can access your own private variables, but not the parent. However, you can access protected variables, just like if they were yours, but the public world can't access them, okay? So let me, to make sure you all understand that, let me just give you a quick example of that. Okay? So I have a class A, which has, remember, by default things are private. So let's just have an int x that's private. Let's have an int y that's protected. And then let's have a public int z. All right. And then let's have a class B that inherits from class A publicly. So we need to write the word public here. And let's just add 3 more variables in there. Same thing. In fact, to save some time, let me copy the word protected. I don't know, that was questionable if it saved time or not. Int j and int k. Okay? So let us see what can be accessed from where. So if I inherit a class publicly, nothing changes. So if you inherit a class publicly, all of the protection rules remain the same. So private are private, public are public, and protected are protected. It doesn't make it less secure. It only makes it more secure. So that was what I was going to say next. If you have all public variables, but you add, instead of putting public here, you put private, then they all become private, which is going to cause some issues if you have inheritance, like if you have a grandchild class, because now everything's going to be inherited privately now. Okay? So you can only make it more secure, not less secure. Okay? So if I have this like this, and in my main I have an object of class A, the only variable that I can access in this case is z, right? Because x and y are protected, so they would give me an error. Okay. For class B, I have 6 variables instead of 3. Let's talk about x or z. Z I can definitely access because it's public. And from main, the only other variable that I can access is going to be k. Okay? Because it's also public. All right. Now let's add our function foo and bar. Okay? So now for a foo, so we're almost out of time. So for foo, just to save some space, let me take this and move it somewhere else. So I can move this closer to that. So I can make it bigger. Okay? So for foo right here, foo is a member function of class A. Foo can access anything. I can access x, it can access y, and it can access z, no problem. It can't access any of the derived classes because it's an object of class A, okay? As long as you're calling it on class A. Next, let's look at bar. Bar, let's look at the local variables first. The class, so I, j, not local, but class variables, I, j, and k. You can also access all of them, no problem. Where it gets interesting is trying to access the class variables from A. From A, z is public, so you can definitely access it no matter what, anywhere. You can access y, and it treats it as a private variable to your class, which is still okay because you're inside the class. But the one you cannot access is x. So x is the one that you cannot access because that one is private, okay? So typically when you're developing your classes, if you intend to use inheritance to expand them, you probably want to avoid using private and use protected instead. Only use private if you really don't want any derived classes to touch these variables directly, and you have set up protected or public modifiers or accessors to your object. Okay? So for example, in the Tamagotchi class, next time we can add a feature and then maybe switch some things to protected, like the HP, so that we can modify the HP in the derived class if we choose to do so. So we'll do that next time. Okay? Since we still got 5 minutes left, let me just show you what would happen in this same example if we modified the class up here to private. So if we do private there, we still can't access the x, but now these become issues right here, the z and the y. They become issues because now when you're inheriting privately, then those variables are being taken as private, which is going to cause issues. Okay? So let us test that and see. Let's just do it here really fast. So let's say class A, int X, int Y, int Z, and then this was supposed to be protected. Public. And then let's say class B inherits from class A, private A, and then I'll just put them in the same line, so I say space. Wait, oops, I, J, and K. Okay? So if I do this like that, and don't forget your semicolons, this is coming out the Tamagotchi game for now. So I make an object of B, and then let's make bar. So try to Z out Z, for example. Okay? Show errors. This is better where I like to see the terminal error, actually. It'll be a little bit cleaner that way. So, error. Expected colon. Oh, well, yeah, that's true. Okay. I still got the right error, but I want to get other errors out of the way. So it says, error, void B bar is private within this context. Ah, shoot, it is private. My bad. This function should be public. It's not wrong there. There we go. Okay, so here, this function, this variable is public, right? But it is now considered to be a private variable. And so if I try to access it like b.c here, like this, whereas in here this is working because it's inside of the class, this one here is going to yell at me and say like, no, this is no longer public. You see this? AZ is inaccessible within this context. So it has turned the public variable into a private variable because I inherited privately, okay? Furthermore, if I have a class C that inherits even publicly from class B, and I try inside of it to see out a variable, so we'll call this bash or whatever. It's going to yell at me. Oh, here, abort. Oh, I'd rather do that here. It's going to yell at me again that, come on, it's, where's my, where I forget it? Here we go. That AZ is inaccessible within this context. Hold on, line 156. That fixes that issue. Here, within this context, is this the right one? Okay, this is the right one. So look, error. AZ is inaccessible within this context. Z out C declared here in function int main. That's a different error. So it's complaining because I have turned a public variable into a private variable in class B, which then by the time it gets to class C is still private. Okay? So essentially, you will convert the variables when you inherit them to make it more secure but not less secure, which may affect future inheritances down the line as well. Okay? So hopefully that kind of gives you an example of what protected would do versus private versus public when you're doing inheritance, both at the variable and function level, but also when you're at the object, like the class inheritance level. So if you inherit the class publicly, nothing changes. Yes. So if you inherit publicly, nothing changes. The whatever you define the variable as in the parent class, private, protected, and public, remains the same, which is why I would say the majority of the time that's how you want to inherit it, unless you know better because you're doing something else. Okay? And then, so does int x become private if you declare a public class? No. Int x remains whatever the parent class was at. So if in the parent it was private, then it will remain private. Remember that by default things are private. So I can add the word private there, but it's the same thing. Okay? So, yep. I am going to make this code compile though by taking out this line of code and then this line of code. Okay, it compiles now. Cool. So that I can I'll still comment those out. So when I share it online and you have it, you can run the Tamagotchi game without like all this stuff causing you issues, you know? When you ever use protected or private inheritance in the real world application, you definitely want to use protected. Actually, well, inheritance itself as a class, you want to use protected variables, but using protected inheritance, not really, because you probably don't want to mess with the public variables. So yeah, I would say you wouldn't really use it. And private, you definitely don't want to use. So, you know, never say never. There's probably some weird edge cases out there. But yeah, you probably would never run into it. Again, unless there's a real reason why. It's like, maybe you took a library from like GitHub that was really cool, but now you're making it like noob friendly. So you want to actually make some things private. So maybe that's why when you inherit it, you like hide things from them. That could be a reason. But again, that's such a weird special case that yeah, you would never see it. So yeah, that's a long answer to say that nah, you probably won't see it. Okay? So that's it. That's the end of the class. So today we did our example with Tamagotchi or finished it. I showed you with inheritance. And then next class we will add some inheritance code to Tamagotchi. I don't know what we'll do yet. We'll come up with it on the fly. Over the weekend, if you want, think about some things you want to add with inheritance, and then we can do it as well, if you have a good idea. Otherwise, we'll probably just add a feature like, maybe we'll make different classes Tamagotchi that have different special abilities or something. And yes, we will do composition as well next Monday as well. So even though assignment 3 will be posted, it probably won't be due for a week plus because we had the holiday, so we haven't finished composition. For composition, what we'll probably end up doing for Tamagotchi is separating the update stuff from the Tamagotchi itself. So, yep. But yeah, so, yep, you will have extra time to do that because I think, because I mean, you could still try to do assignment 3, but, you know, it'll be a lot of complicated stuff if you see like inheritance because we only really just gave you the most basic of examples so far. So, yep. Okay. Other than that, have a good weekend, everybody. Thank you all for watching, I guess. Great. Well, I'll catch you all later. All right. Take care, everybody. Email me any questions you might have or Discord. Have a good weekend as well. Thank you.